everybody, my name's Cliff, and I'm going to talk to you really. The theme, as has been said, is the intersection of technology. Thank you so much. The intersection of technology and social, and so the way that I sort of think about this is, I definitely don't build social networks. I just use them for performance art. So instead, I'm going to talk about my experiences building a team, building a company, the things mainly that I got wrong, and the anti-patterns you probably shouldn't do. So that being said, my company is called Boundary, and I want to take you back to the very beginning, to when it got founded. And there's a really good quote from a friend of mine. This is the most amazing thing that I've ever heard come out of his mouth, and he said a lot of really amazing things, is that a systems engineer without a good startup idea will inevitably end up doing monitoring, which I just think is wonderful and also heartbreaking, because then I realized it applied to me as well. So I was at a company called PowerSet for a while. Really cool place. It was my first Silicon Valley startup thing, and since I was in high school, I wanted to. So I went to high school during the first .com boom. Back in the '90s when Yahoo was still cool. I was like, oh my God, I got to go out there and I got to do this. That was my. And then the big crash came, and I flunked out of college and blah blah blah, and all that kind of stuff. All that stuff happened, and it looked like, oh, the dream is dead. But then suddenly, Google went public. The dream became alive for a lot more people. And it sort of came back, and which was cool, I think. So what did I end up doing? I ended up, moving my whole family out to California, joined a company called PowerSet, and there, I sort of learned the ropes, or the beginning of learning the ropes for doing startups. So we got bought by a company called Microsoft. You might have heard of them, and then immediately thereafter ground into dust. Microsoft has this way of digesting the companies that they acquire. Kind of sucked, but after I got out of PowerSet, I said, I really want to do a startup, and really the obvious choice seemed to be monitoring because of this. The idea really was we wanted to concentrate on the network. The idea there being that the theory was there's no tools. This was like in the beginning, the early days of EC2. So there's no tools that could really look at cloud traffic. There's no tools that could actually give you good network data in a completely software delivered way. So we thought there was an opportunity there. But the problem is in that sort of environment you don't have access to the network hardware. Honestly, we had no idea about the shape of the data that they produced. In other words, we knew they produced a lot of data, but we didn't even know what, between network manufacturers, we didn't even know there's different specs for each and every switch and each and every router. So, we didn't have, we were basically starting from zero, which is kind of bad. And what we ended up doing was we adopted a software agent called Magi. It was this weird little project out of New Zealand, and it was an open source project, so we started using that, and so the main design goal, honestly, this was as much as we had thought it out. We said, okay, we want to produce an API that spits out your network data and looks like Google Analytics. So is everyone here used the Google Analytics API? Yeah. Okay. Yeah. So the Google Analytics API is this. The idea was dimensions and metrics, right? So taking a set of metrics, aggregating them over a different set of dimensions, and basically being able to roll up tremendous amounts of data by categorical, in these categorical columns. So in other words, being able to make a query like for instance, if you're getting attacked by China, you might want to be able to roll up your network data in such a way that you can see that and you can visualize it, but you need to have this ad hoc aggregation ability after the fact. So we went about testing this with early prototypes. This is the beginning of the NoSQL days when everything was still extremely terrible. So our first iteration was over the 0.20 release of HBase. which actually the interesting part is that we paid for our servers to actually stand this up by doing consulting work for Basho. Thanks, Justin. So very much bootstrapping, trying to get things off the ground. So we built the prototype, and this gentleman, who's actually a competitor with our previous presenter, he broke it for us. So he was actually Arthur was great because he was our test bed for these things. So essentially, we would produce the prototype, build it all up, and then ask him to put a meter on one of his gigantic CDN cache machines and just spew data at it until it breaks. Which is great, and he was very good at breaking things. So he broke it. What ended up happening was that there was actually a bug in that version of HBase. So HBase would fall right over, and it would forget that it was serving the master. It would forget that it was serving the master region, which is the lookup table that it uses to tell which server your data is on. So that's kind of a bad thing for it to forget about. So back to the drawing board. And we really, we said, okay, well, the HBase thing's not working out. Yeah, there's a bug in that version, but, this is an inflection point, a chance to say, what are we actually trying to build here? So we started doing some research, and the thing that came upon us was like, oh yeah, that dimensions times metrics thing, like that's actually an OLAP system, and there's this big body of research for it. Maybe we should read some papers. So we started reading about OLAP data models. It's an n-dimensional hypercube. It's very simple. N-dimensional, yeah. But anyway, like you can visualize the entire space as a, so if you're having 7 dimensions, it's a 7-dimensional cube, but we keep it to 3 dimensions in the diagrams to make your brain not explode. So you think about any sort of query you can do in this type of model is actually a subcube. So if you want to take a slice out of it, this is actually when data modeling, when analytics people talk about slicing data and pivoting data, they're actually talking about literally like taking things in an n-dimensional plane and slicing through it. So cool. So we did a bunch of research. We went out and talked to people in the field who were doing these who were actually researching a lot of the OLAP primitives. And we came up with this idea, we actually stole from a paper, this idea of minimal cubing index. So we figured we could make these 3-dimensional subcubes of the n-dimensional space. So it limits the amount of index that you have to build. So you don't end up in a situation where you're building more index than because if you try to index everything, as a cross product, you're going to end up with more index than actual primary data, which is bad. So we put together this sparse, basically these sparse tables, and we put it all on top of Cassandra. This is kind of what the cuboid table looks like. It's basically like a reverse index. So if you've ever built a search engine or like looked inside Lucene, it's extremely similar. We built it on top of Cassandra. So we hacked this thing together in about a month. I think I locked myself in my home office and didn't see my wife or child for quite some time, and just hacked away at it and built it all up. And it actually worked, which was shocking. It's worked with smaller data sets, but our friend Arthur still broke it. He's good at it. What can I say? So the interesting part though is that we could actually keep up with the ingest rate. So as data was coming in, we actually kept up with the write rate. Turns out Cassandra's really good at writes. Once we looked at the app server during the query times, because the query times were extremely slow, and we found out that what it was doing is, if you're using Cassandra through the Thrift interface, which is all it had at this point, as it was fetching indexes, it was actually fetching like 10 megabyte indexes back and forth several times per query. So that's clearly had some data locality issues. Okay, cool. We'll do that Hadoop trick, right? We'll move the computation to the data. And this allowed us to come up with the idea of a project that we called Scylla. So we took all of our logic, all of our business logic and indexing logic, and we basically just shoved it inside of Cassandra. So we cracked it open, forked the whole thing, built all new query paths, all new ingest paths. So we bypassed all the thrift stuff, we bypassed everything. And it was essentially dealing just with raw SS tables. And so the indexing and query planning code all went in there. And we mainly, basically built a distributed database with just the parts of Cassandra. And so it actually was a pretty good prototype. It worked. Arthur stopped breaking it, which was nice. And so on the back of this prototype, we actually got funded. So it became like a real company. Could hire people to actually build a real product on top of this thing. So it was cool. Which brings us to the post-funding era. So it turns out when you take money, you have to like build a product that goes out and makes money, right? So you have to go out there, you have to sell this. But the problem is that we were having trouble scaling the system, right? So we were having issues with people, larger and larger customers coming on board. The problem with Scylla is that it had extremely bad load balancing. So the load balancing was literally like the hour part of the timestamp along with the customer as a tuple. There was indexing race conditions. There was a bunch of bad stuff. And the Cassandra data format was not ideal for the type of structures that we were building. We really we looked at it and we were like, okay, we're on kind of a weird path here, and if we keep going down this weird path dependence, we're going to end up just rewriting the storage layer of Cassandra, which is a pretty big undertaking. So we kind of took a step back and said, okay, can we solve an easier problem here? Like, what are we actually trying to do? That's where we came up with the idea of streaming. Right? So instead of trying to do all this on disk and then pull it back out as a query, we'll try to compute everything on the fly as it happens. We can store off the resulting aggregates. And but the cool thing is that we can use WebSockets. We can push things to the browser immediately, so people get that immediate feedback loop of what's going on their servers. So it's like, cool. That's actually a vastly better experience than most monitoring dashboards, because no one had tried to do a streaming dashboard yet that we knew of. And so instead of having to explicitly query things and request them, you can have it just stream to the browser. Think, okay, cool. So we built this thing called Streaker. The first prototype actually used Esper, which is its own nightmare in its own way. But we finally thought we had something that we could scale out and that we could build a real product on. And that's when we started to build out the team and then build out. And that's where you come to the social side of things, because as soon as you build out a big team, you need to build a culture, and all these things start to really matter. And so the key thing that we learned is that the key takeaway here is like the team and the culture actually build the product, right? And so that sounds kind of like a truism, but like it has some profound effects, which I'll show you. And what do I mean by culture? Because startup guys like to talk about this word a lot and can't really define it well. So I'm for the purposes of this talk, startup culture I'd say is a shared set of values, right? Like how do you make decisions? How do you go about your daily work without locking, right? Because I think in terms of distributed systems. So culture is actually a distributed consensus problem, right? So you have a team of individuals who can only talk through a lossy network of talking to each other. And so a strong culture is a strong consensus, so that you can all sort of run in parallel without having to check in on everything, right? You can think about it two ways. You can say like the eventually consistent system is the one where everyone just goes and does their work, and somehow they all come to the same conclusion because of the invariance of the system. Versus a culture with a strong process, which means you have to get approval for everything. That's like three-phase or two-phase commit, right? So for us, what we learned here is that the culture and the technology, though, they tend to reinforce each other. And so the choices that you make in building the culture, they affect the type of choices that you can make in the future, right? And so, in other words, if we had stayed on the Cassandra path, right, and had not decided to scrap the requirements of that and just scrap the whole thing, we would have been path dependent on having this weird Cassandra code base, and basically the way it looks is going to be the way it looks. The way it looks today is going to be the way it looks in the future. Like you're not going to change the fundamentals of the system, right? So if it's a streaming system, it's always going to stream essentially. If it's a query and response type of system, then you're always going to have that dynamic in talking to it because those things are too hard to change. That's what I mean by path dependence. And it turns out that there's path dependence in your culture as well. Because this idea of the Overton window. Is anyone familiar with this term? Yeah. So the Overton Window it's from political science, but it's this idea of there being a spectrum of acceptable choices that you can make within a culture or within like a polity if you're talking about political science. But essentially like so in other words, like you wouldn't expect that George W. Bush to go say free abortions for everybody, right? Like that's not going to happen. That's outside of the Overton window of his base. So you wouldn't expect me to say yay no JS. Like that's outside of my Overton window. Like I'm not going to do that. So there's this spectrum of acceptable choices that you can make as a leader or as a manager or whatever. That if you make a choice outside of that, you basically you risk alienating your support. That's how you form path. That's how path dependence and cultures form. Is through your Overton window, because as you move along, the choices you can make get narrower and narrower. And so we built. So what was the team that we built? We built a team of systems engineers. Was the original team that we built, and the systems engineering culture is very different from product engineering. So product engineering culture favors shipping fast, basically shipping things that are probably going to break. You don't worry about the operational cost of things. Systems engineers very much worry about the operational cost of things. Because what we were trying to optimize for was we have this system, it needs to process a lot of data. It's a very hard problem to solve, but we think we can do very well with it. But we need to have this systems engineering culture, and we really got this. The idea that got instilled in us is that our scale breaks everything, so we have to solve all the hard problems. There's another concept as. So I don't know if there's any Finns in the room. So this is a word from Finnish. Sisu, I'm probably butchering the pronunciation, but it's the idea of grim determination in the face of complete failure. So that was like, if you could sum up the culture of the first team, that's what it was. Like that's yeah. And so we became, it was really interesting. We became deeply suspicious of all open source software because we'd seen so much of it fail, right? And so anytime a new NoSQL database came out, we were like, oh God, more of this crap. The problem is that as soon as you get suspicious about everything that is going on out in the world, you get this, like, it sort of becomes a default choice that, oh, we got to bring this in-house because clearly the open source stuff is going to be crap. It's going to fall right over. So we built a lot of stuff in-house. We built our own query engine. We built distributed load balancing. There's a lot of plumbing. The problem though that we ran into is that when you build these things in-house, you don't necessarily build them to be flexible, to be for like multi-purpose. You build it for one thing, and it does that really well. The problem though, that might be fine, right, as long as everything's going well. But we had a lot of commercial pressure as well. So there was a lot of pressure to get new customers, close deals, do custom work, right, for individual customers, because as soon as you're talking about selling a big enterprise deal, everybody wants something different that built on top of it, right? So shipping, and then we really got into the mode where shipping features was gated on core infrastructure work because of the inflexibility of the system that we built below, and then scaling it for bigger and bigger customers as well. So like we were having to do all these things. And it's just like, it just became a real struggle to keep up. And this is what they talk about, like, when you get down in the hole of technical debt and you can't get out, right? So over the past, maybe a bit more than 6 months, but essentially we wound up in this position where it's like, we have this real lack of engineering bandwidth. We can't tackle everything, so how do we get ourselves out of this technical debt hole? How do we, how do we get back to being an organization that can ship a lot of product and get it into customers' hands quickly? So again, another inflection point to reevaluate things. There's one of the things that we thought about was like, is there something out there we can take off the shelf? Is there open source that we can use? Is there, what can we do here? The one thing we knew we couldn't do is that I don't think there's any such thing as a successful rewrite. You don't rewrite an entire system that conforms to not just the requirements of today, but the requirements that are going to come in while you're writing it. This never works, right? I've never seen this work properly. So, if you're trying to rewrite the system, you should prefer the mutation of working software over a full reimplementation. Of course, if you do this wrong, you can end up with more technical debt, and So we came to this point where it's like, okay, well, let's ship something different. Really, when we reevaluated, we said, look, do we want to be doing big enterprise deals? Do we want to be selling to people who want custom everything? So we really came down to we might need a different business model for this new thing that we ship. And if we do that, then we can actually ship something completely different, not based on the same platform. We can use what I would call prototype grade technologies. Not everything has to be absolutely bulletproof, as long as we can get it out there and prove that it's going to be useful to people, right? You can have a much smaller set of requirements and then focus on user experience and focus on more of that fit and polish type of stuff, as opposed to focus on the fit and polish as opposed to trying to build the most scalable backend and focus on the plumbing. So, one of the things that we realized was that the prototype quality code, asking a systems engineering group essentially to build prototype level code, it's out of the Overton window. They're not going to say use Redis. What? Get out of here. So it's like, how do you shift culture? And the way that we did it was bringing in new people, right? So we went out and found another monitoring company, small monitoring company, of a couple people that were doing 1 second monitoring, brought them in, and they've been leading the charge since then. Because culture really is inertia, and software is made out of people, right? And so if the culture builds the product, you can't help but these things are reflections of each other, right? And so the systems engineers are going to build a big distributed scalable system, whereas the product guys are going to build a product. And I guess one of the interesting things that I've heard from a number of people is that it's just software, man. It shouldn't be this hard, right? When you look at what you got to produce, it's like, okay, some graphs. It's a chart with some graphs. It's just some alerts, right? This is all just software, but really what it comes down to is software is made out of people. It's made out of organizations, and all of the trouble that comes with having an organization full of people. That's actually what you need to deal with, and that's actually what causes all of the friction, of what you think should just be some simple software. I don't know. It's a projection of the organization. So this has become my personal mantra. Let's make different mistakes next time. So I tend to learn through being arrogant and having hubris, and then getting smacked down by the universe, and getting back up again and saying, well, I'm going to do something different next time. And so anyways, that's me.
Questions? Somebody asked it.
Yeah, just about the change. I mean, you sort of, on the one hand, you talked fairly explicitly about, say, the new owners, the fact that money came in, and managers who've been this route before and had successful exits and so on. Just how wrenching was that shift in terms of in terms of setting up that culture when you had these very managerial class people coming in?
Yeah, terrible, painful. Culture's inertia, and people are going to resist that change, and it's people get very emotionally involved in their companies, right? You bring someone in early, and they have a real sense of ownership over it, and it's like. They get real defensive. It's just like, who are these people? Why are they here? I don't like this guy, right? Literally, it could be a reaction of I don't like this guy, and you don't even have a rational reason for it. So bringing in new leadership is can be gut wrenching, right? And you look at startups that fail or startups that fizzle out for some reason, and inevitably, I wish people did postmortems of failed startups, or they did it more often. I know a few people do, but they might not even be all that honest. But it's I think the teams and organizations, they fail just like distributed systems. It's you have these complex. You set up these complex web interdependencies, and you fuck it all up, and it all crashes down to the ground. and you need to like look through and say, okay, where did we actually go wrong? Like, how do we avoid doing this in the future? I think people do that in private, but they don't actually publish their results out to the world. So again, we're still working in like folklore land when it comes to building teams and stuff like that, or at least small teams that build product. So yeah, I don't know. It was a rambling answer, but to answer your question, yeah, it sucked.
Well, I'm curious about the, obviously you went through I wouldn't call it necessarily not invented here, but hey, we need to build sort of everything ourselves.
Yeah, I mean, no, you can definitely call it not invented here. I mean, it was a certain flavor of that, but the same result, right?
So in other words, how do you, you mentioned, okay, hey, there's a reevaluation period and so on. Like, how do you get people, if you're sort of addicted to, we need to use the best tech all the time, and if it's not perfect and we can't use it, we're going to build it ourselves, and it turns out that doesn't necessarily scale all that well for a smaller team and so on. Like, how do you begin to shift that conversation and say, look, this does fall over, this does have these issues, but you know what, it does 80% of what we need, and we don't have to build it.
Yeah. So that's a great question. So what I found is that a lot. So it turned out it was actually kind of a small thing, but it made all the world of difference in trying to have that conversation with the team of back-end engineers. And basically what it was is that if you looked at the amount of time so they were looking at it from the perspective of, they don't actually like really care about what we use necessarily. They care about how much time they're going to have to spend in the future maintaining it.
Right.
And they worry about getting called to task over the fact that something is down, something is wrong, customers are complaining. And so what it takes there is to say, oh, okay, that's what you're concerned about. And then you remove those negative factors, right? The negative factor of you're going to be called to task over this. Say, yeah, you know what? If it goes down, yeah, that sucks, and we got to get back up. You're not going to be. No one's going to yell at you for this. No one's going to be angry at you over this. You take that out of the loop. You say like, look, we'll shit umbrella over top of you. We won't let you get hit. And the other part of it is that we'll over provision these systems such that you won't have to burn your life away on keeping something running that's really sort of filled with brim. So I mean, those are the two things. Like people don't want to have to wake up and they don't want to have to bring out the laptop during their kid's birthday party to fix some bullshit in production, right? Like they don't want to do that, and they don't want to be yelled at while they're trying to fix the bullshit in production at their kid's birthday party. Like, that's like the worst of the worst, right? You're trying to do the right thing and someone's screaming at you. So removing any connotation of like there being any kind of negative aspect of that, like that helped tremendously. But it's still, it's like steering a container ship kind of thing in terms of what people are comfortable with.
Okay. Blameless downtimes.
Yeah.
There you go.
Yep. Which, I mean, if you're selling to big enterprises, so I mean, that's why a different business model is required, because you need to have a freemium business model for that. Because if you're selling to gigantic enterprises, like they're not going to stand for it, right? Like, like I paid you, blah blah blah. And why is So it's different expectations.
Okay. We're good.
Yep.
Awesome. Thank you, Cliff.
What's that?
I just want to say thanks for the transparency. I think in the technology industry, every company has a we're walking to every moment, multiple moments. We've had ours over the last 2 years.
Oh yeah.
Nobody talks about them.
Yeah, nobody talks about them. I mean, sometimes you're legally prohibited from talking about them because you sign contracts. None of this was in any contract, though. I checked, so that's good. Yeah, no, it's I think people should be more transparent, because whenever you hear the stories, everyone's always crushing it and like rah rah rah, go team. It's like, man, fuck you. You were crying like a week ago. I saw you crying into your beer. Like, shut up.